Hi, my name is Nate Nestler, and this is for Hyperactive Studios. Now we're going to continue on with some more Java here, and we're going to start going into what's going to be the third video in the series. Now I just created one called If Test. If you go to File, and then New Project, you can then choose Java, Java Application, and then type in something like If Test. Of course, I already have one. And then you would say Finish at this point. I've already done this. So at the top here, I need to import java.util.scanner because we're going to have it where people can type their inputs through command line. I'm going to be going back and forth between command line and graphical throughout the series, so that way you are well-rounded on both sides of the coin as far as that goes. So import here space java.util.scanner semicolon. Alright, and that lets us import the ability for people to type input into our programs when it runs, just like we did before. So our class, of course, is if test. Now note, this is something important, and I should probably point this out. Your name of your file must match the name of your class. You cannot change this. This needs to match. I don't remember if I mentioned this or not in the first one, but these two have to match. You cannot have them be two different names in Java. It's not allowed. So you are required to have it this way. Then I created a whole series of constants. So I did static final float, and here apples underscore cost equals 1f semicolon. And I did the same thing over again. Peanuts cost, bananas cost, muffins cost, bagels cost. And I just assigned different values for them. So $1, $1, $1, $2, $2. These are constants, so if we need to change the price in a program later on, we can just go in here and just change this number at the top, and everywhere where this is used in the program automatically gets changed. So this is a great way to do it. Also computes faster because this is pre-processed, so you can get computed prior to the rest of the program. So there's a lot of benefits to this. Some people might be thinking, why not do enumerated types? Well, actually enumerated types can be done in Java, but it's just about like creating a class, and so they end up being far more complicated than you might imagine them to be. It is actually easier and more probably memory cost effective for me to define a whole series of constants than it is to create enumerated types in Java, which is kind of frustrating in my opinion, but that's the way it is. So they have enumerated types are not in Java are not like enumerated types in C++ or another language, and so it gets kind of complicated on that. But we could basically do something just like this with enumerated types, but in Java it'd be quite a bit more work. So we're gonna just use constants for this instead. All right. So static here. Plus we need to assign certain values to it anyway. So enumerated types probably wouldn't be the best choice. This is probably the best choice anyways. Period. All right. Now we have the scanner here, and it is input. There's a new scanner system here, and we are creating a variable called input. So basically it's a static scanner. You might be going, why is it static? Well, it has to be static because we're passing this into the main, and so because this is going into main is static, so therefore all the others have to be static. That's why we had to make our functions or methods, however you want to call it, static. And this is why we're also going to have to make our variables here static. I'm going to end up just having to make them all static. So static scanner here, input, insub type scanner, equals new scanner. So we created memory. It needs to be the size of system.in, because we got input coming in on that. And then we're going to do a static int here. It's going to be choice is equal to 0, semicolon. Static float cost equals 0f, semicolon. And then we're doing an if test here. So input equals new scanner system dot in. And this is what I was doing as constructor. I was showing how you can go about it, but I ended up having to put it up here anyways. And choice will be initialized at 0, and then cost equals 0f, semicolon. So if I was doing a constructor, this is how you do it in Java. You don't put void or anything in front of it. It has the exact same name as your class, and then you have open and close parentheses. You could pass in different parameters in here to set it if you wanted to. But yeah, this is essentially how it works. All right. With that said and done, let's look at our options. And cost, of course, is a float f, 0f. Okay. Static void options here, open close parentheses, open curly brace here, system.out.println. And I'm basically just telling them what their options are that they could input. And I don't need to return anything. You might be thinking, well, wait a minute, you're doing choice, so shouldn't you be returning something? No, I really don't have to, because choice is actually a property, or aka a variable that's part of the class up here at the top. So since that's the case, I really don't have to return anything. Once I assign this value into choice, it's assigned into the class property. And so choice now maintains a certain value. On another note, in Java, if you don't define public or protected, then it is by default private. So all these are private and no one can see any of these. So you might be wondering, well, can't someone see all these different variables here, access them? And the answer is no, they cannot, because it is essentially private. So I could also write it this way, and it's the same thing. So I could say it like this. And that would be the same thing as just leaving it as static. So if it's not marked otherwise, then it's automatically private. And that's something important to remember, because you might go create a property and you might go, well, why can't people see it? Because it's not automatically public, it's automatically private. So you must mark it as public if you want people to see it. So that's kind of what the deal is there. But right now this one's private, so that's the way I want it, and it works out great. Anyways, I display different items listed here. So apples, peanuts, bananas, muffins, bagels, and I let them choose which one they want. Then I take those values and I input them and store them into choice. I take it as an integer. I can just show you how this whole program runs. Yep. So now it asks me which one do I want. Say I want apples. 1, enter. I get my choice as apples. You still want to buy, true or false? I'll say true. Type out true, hit enter. Alright, which one do I want to buy? How about muffins sound great, right? So let's do 4. Alright, we get muffins. Maybe this is a little barista or something like that, at a convention or something of that nature, right? Alright, so I want to buy something else. Let's buy a bagel. Alright, true. Let's get a banana, and then let's call it quits. No, I'm done. I don't need to buy anything more. Alright, my bill is $6. So that's how the program works. So this is the input part where they're selecting which one they want to buy. And then we do that with a function called options. And again, this one's private because we didn't say otherwise, so therefore it's private. And if that helps you, you could put private in front of it like that if you like. If that helps it make more sense. And again, I could put private here in front of output if it makes it more sense. So then we're going to create another one called output, right? Open curly brace here, and then we're going to do an if statement. And we haven't talked about if statements before, but basically what if statement is it lets you do a test condition. You're basically saying if choice is equivalent to 1, so basically if 1 is stored inside of choice, basically if someone selected 1, which would have been what? Apples. So if someone chose an apple, which would be 1, then do this, system.out.println apples, output apples, and then say cost plus equals apples underscore cost. So we increase our cost by adding up in our cost property based on the different values here from our constants. So in this case, we're going to do apples. But if they didn't choose 1, maybe they chose 2 peanuts instead, right? Then else if. and the choice here is choice is 2, then it will actually display peanuts. And we're going to add the cost of peanuts, which is $1, right? So we're going to add that on. So this is plus equals, remember? So this would be the same thing as if I wrote it as cost equals cost plus peanuts cost. There we go, like that. And what this will do is it will increase the amount here. So we'll get the value from cost, whatever the amount is stored inside the cost here. And then we're going to add that to the value of the constant, which is peanuts cost. You notice that peanuts here is all caps. This is to help us, and you separate the words by underscore, this is to help us differentiate in our code between constants and variables. Because once you have a constant, you cannot assign another value to it. It's fixed. But in the case of a variable, you can assign another value to it. And that's what we're doing with cost here. So this will never change throughout the program while it's running. But this can because it's a variable. Okay, so I add it on, and these two values get added together, and it gets reassigned back to cost at the end. So it's going to be $1 greater afterwards. Anyways, that's how. But by saying cost plus equal, it keeps you from having to say cost equals cost plus, and this lets you do a shorthand. So this is really useful, and practically every programmer uses it because of that. Okay, cool. But what if they didn't choose? And you know what? And if they did choose peanuts, then it would skip all the rest of this if-else stuff right here. It'd skip all the rest of it because it basically found what it's looking for and doesn't keep looking for it. So that's the difference between doing a whole series of ifs versus else ifs. There might be something where I need to be able to check for something more than one place and see if it comes out to true. Like if you do a joystick on a game, you need to be able to go forward and to the side. So maybe I'm going diagonally forward. Maybe I'm going forward right diagonally. Well, if I did a series of ifs, that would work. If I did a series of else ifs, it would not work because what would happen is on the first, when it detected like going up, for instance, it would do that one for applying the forward force to the character, and then it would not do to the side because it would skip it because of the else if. But if I did it as a series of ifs, it would go apply the force up and then apply the force to the left, and then thus apply making the character run diagonally to the well, not to the left but to the right. Sorry, I said right earlier. So yeah, right. So then the character would run forward to the right diagonally, and it applied it to the right. In the case of this, though, we're only making one selection, so it can only be one of these things: bananas, peanuts, etc., apples, muffins, or bagels. So because of that, I'm going to absolutely want it to only be one thing, and it's a waste of time to keep checking the rest of it. So else if is the ideal thing for this. So it depends on what you're doing as to which one you use, and you have to make that decision yourself. So in certain circumstances, it'll be more efficient to use else if, and in other circumstances, else if will make it not work properly for the logic. So you have to determine that on your own when you're coding this stuff. But in this circumstance, else if is the ideal structure here to use for this. So, and again, I have open and close and curly brace here for the starting and ending my else if condition here. And you can copy and paste this stuff. You can just like select a whole block of code like this and say Control C, and then Control V to paste it, and that will save you a lot of time. And then change choice to 3, change your printout to bananas, and then change this to bananas for your cost. So we're going to display bananas if they chose number 3, and we're going to increase our cost by the amount of bananas, which is $1. All right, we're going to paste again. Set this to 4 for their choice. In this case, they've chosen muffins, so you put in muffins. And you say muffins here for your constant, and now it's increased it for the muffins. Then paste again, change it to 5, and type in bagels. And then you're going to say bagels here for your cost, like that. And these two are $2 each. Both of these are $2. And that will increase the cost for bagels. If they type something they weren't supposed to, you say incorrect choice and display that, because they did not do what they were supposed to do. Okay? So that's how if statements work. It lets you do a test a condition here and see if something's true. This lets me see which one they selected and then increase my cost accordingly. I can prove this. Why just talk about it when you can do it? So I'll get into switch statement later. All right. So this is using our if statements that we did. You might be going, why are you doing that? Well, as it turns out, I need to. And the reason I need to need to do a step over. Now this time I need to step into it. And then this is going to literally show where it's creating the interface one by one. Oh, I said I didn't mean to do that. Sorry, that was diving directly into the println function and making it happen. I don't want to do that. But see, as I do each one of these, it displays it onto the screen for displaying it, printing it out. In the enter option, we're going to take in our input choice. Let's say I choose 3 because I don't want it to happen right away. Alright, so I'm going to stay step over. I'm going to jump into my output and check it out. Does 3 match? Now, check this out. Look at my variables here. Does 3 for our choice. See that? Our choice is 3 right here. Our cost is 0 because it got initialized when we first created this thing. And we have our different constants with their different values here, right? It's very cool. So is choice, which has a value of 3, is 3 equivalent to 1? The answer is no. So we're saying if it is, then do this code here. But it's not, right? Because 3 is not equivalent to 1. So what the double equals means, it means is equivalent. So we're checking the value inside of choice in memory with 1 and see if they are the same thing. And they're not. This is different than a single equal sign, which would assign this value to this variable and replace this value in memory. This checks to see if they are the same. This is an equivalency check. So it's going to skip it because 3 is not the same thing as 1. Then we ask the computer, well, else if the choice, then in that case, if it's not the one above, well then, is this choice equivalent to 3? And I mean equivalent to 2. So is 3 equivalent to 2? And the answer is no, it's not. So it's going to skip this one. And so we're not going to do peanuts. And it comes down to else if. And it says, well, if it wasn't any of the ones above it, and is choice equivalent to 3? And if choice is 3, so is 3 equivalent to 3? Then yes, it is. So now it's going to come into the structure here for your if statement. And it's going to do all the code that's between the curly braces because that's part of this if. That's what the curly braces are all about. This is like a way of saying start this condition code. And this says to end the condition code. And this is all the code in between the two conditions. I mean, between the open and closed curly braces. Sorry, better way to put it. For this particular condition. So that it does all this code. So what we're seeing here is going to display bananas. So let's step over it and see bananas appear. Alright, bananas it is. Back to our variables. Alright, so it's going to grab bananas cost, which is 1, right? And it's going to take cost here, which is 0. We're just going to step over that. Boom, like that. And our cost is now 1, right? Because it took cost, which was nothing, added 1 to it, which is from bananas, and and then afterwards it assigned it back the cost, and so now our cost is 1. Okay, we're done. You may have noticed that it now skipped choice 4, choice 5, and the else. Reason why is because we have this else if, so once we find what we're looking for, it doesn't keep looking for it. So that's the beauty of else if, and it saves you a lot of time in your computations. As you can see, it skips all that code, so therefore we're not having to compute it to do our determinations. We're done. We're out of there. We're good to go. So makes a difference. And then it's going to display, do you still want to buy? True or false? And I go boom, like that. If we look at our output, it says that. And then it's going to give us our input. And now we type in our choice. And I would literally come in here and say true. Like that. And I say enter. While buying will let me do another one, which is options. I dive into it and I step over it, and it's going to display all that stuff again as we do each line of code and then take in our choice. This time I'm going to do muffins. Oh gosh, no. I meant to have it down here. Sorry, 4. It's the downside of this, right? Alright, step over that and step into our output and see what happens. So it's choice, which is 4, right? Is that the same thing as 1? The answer is no, it's not. So it's going to skip it. Is choice 4 the same thing as 2? No. Is choice the same thing as 3? No. Is choice the same thing as 4? Yes, it is. So here it goes. It's going to display muffins. Look at our output here. Bam, there's muffins. And that's going to increase the muffins cost. So I'm going to come back to my variables so we can see that. So our cost is 1, right? So it's going to be 1 plus muffins cost. Muffins cost is 2. So 1 plus 2 is 3. And so our cost is going to end up being 3 afterwards because the 3 is going to get assigned back to our cost variable. So if I step over it, bam, cost is 3. Step over that, print, do you still want to continue? Output, and it's asking me, and I'm going to say false to this now. I don't want to keep going. And so it's going to display to me. We're going to exit out of our loop because our loop is now false. So this loop only keeps going while it's true. So that's what's going on. That's why it kept repeating like that on this code. You might be going, why? Where did that come from? Well, Boolean is a variable type that's true or false up here. And this lets me essentially keep repeating this code over and over again while it's true. The moment it becomes false, it stops repeating the code. So everything between these curly braces gets repeated over and over again. And that's the beauty of a do while or a while. It's condition-based looping. It just means something repeats over and over again until while it's true. The moment it's false, it stops working. So now, bring this home. Buying is false, which means this while is false. It means it's going to jump out of this loop. It's not going to keep doing it anymore. Boom. So it's no longer in this loop, and it's going to display the bill. And the bill is getting displayed, and we're done. That was the end of the program. So I should have shown that. Well, I already did from before, but let's say I chose number 4, right? Gosh, dang it. I gotta stop doing that. Oh, man. I was going to say false and have it display. See, afterwards, it displays that your bill is, in this case, $2. So, yeah, it works. Okay, so that's what's happening there. So that's essentially how all this code works. And we just have this in the main here, where we had to create a boolean called buying equals true. And we have a do here with an open close curly braces. And then we just call our functions. Options is going to display our menu options. Output's going to determine what the output is from when you're basically doing the purchase selection. And this asks us whether or not we want to keep buying. And then we assign what they chose, true or false, back to the buying variable. And that directly affects our while loop. Once it's false now for a while loop, we exit. But while it's true, this loop keeps looping while it's true. And the moment it's false, it exits out of the loop. So then we can tell them their bill and what the cost was. That's basically it. But not only can we do it with if statements, we can also use another structure. And this gets into my output switch versus my output. This does the exact same thing, but it's a different programming structure. And some people prefer it, and some people don't. I tend to prefer ifs, but if you like, switch can be a little neater at times. It's limited in what you can do with it. The if statements are way more powerful. I haven't gotten into it, but with if statements, you can actually do all kinds of logic tests for greater than, less than, greater than, equal to, less than, equal to inside of ifs. You can also combine multiple conditions with and or. I'm not going to get to it right now. You can't do any of that stuff though with a switch. Switch can only test one value. So it's great for a scenario like this, where you can test one value after another like this, because it makes your code really compact and short. It makes it easy to read and all this stuff. So switch statements have been around for a while, and they're just preferred by some programmers. And so they really aren't any different than an if statement. It just they're just a little simpler to read, basically. So if I come here into my switch, I tell it what variable I want to test for all my different cases. So that's the other thing. You can only test one variable for all your different cases. And you say switch in here, and you say I want to be testing the choice variable. This works because we're choosing between apples, peanuts, and it's all with the choice variable. So open curly brace here. We have case space 1 colon system.out.println, and it's going to be apples. And then we say cost plus equals apples underscore cost semicolon, so it's our constant. So you notice this code is identical to the code that was in between the curly braces inside of our if statement. But this one's new. This is called break. This lets you exit a condition like switch here, and also use it to exit a loop too prematurely. So before the loop is supposed to end, you can use a break statement to make it exit sooner rather than later. That's exactly what we want to do with this condition. We want it to exit sooner rather than later. With the ifs, we had else if in order to help exit sooner rather than later. As soon as we found what we're looking for, we exit out of the structure, out of the condition. But in the case of a switch case statement structure, it doesn't quit. It acts like a series of ifs, which is great if that's what you need to do, but it's rarely ever what you need to do with a switch. So you must always have to have a break semicolon here. This lets you leave the switch statement right away, and you don't keep looking for it. So after you find like case 1, you don't keep checking for case 2, 3, 4, 5, etc. That's why you have to put this break statement in there. Otherwise it will. So then after you type up that first one, just copy and paste it. So select it and say Control C as in cat, and then you're going to paste it as Control V as in Victor, or victory, whichever you want to say. So Control V to paste it. Change case to 2. Change that to peanuts. Change this to peanuts. That's good to go. Next one. Paste it again. Bananas. Bananas. That's it. And that becomes 3. Paste again. Case is going to be 4. It's going to be muffins. And then muffins here for that. In case 5, put a 5 here. Bagels, bagels. And default incorrect choice. And that will do all those different case conditions. And this will act exactly, we get the exact same results with this that we did with our if statements. And you won't be able to tell the difference when we run the program when we're using one or the other, because they do the exact same thing. And on our default, this is like our else. So we're going to say incorrect choice, period. And that will just let them know that they made the incorrect choice. Now if we run this, we'll get the exact same results. Check it out. I could say 3 here, for instance. It's bananas. If I say false, it will, well, I need to spell false correctly, right? It always helps. and bananas was $1. Perfect. Let's step through this though and see this in action. So I'm going to step over. I'm going to step over my options getting displayed because we've already seen this a bunch of times. So if I do that, it's automatically just going to display all that there. That didn't change. Use the exact same function as before. And let's choose bananas from before. So number 3, enter. Okay, it's going to go to our output switch. Let's step into our output switch and have a look at this. Now in memory, you'll notice that our choice is 3. All right. So if I step over this, immediately skip past case 1, case 2, found that it matched case 3 because choice was 3, so it jumped right to 3. And then system.out.println is going to display bananas. And it's going to add to our cost. So if I look at our variables here, notice our cost is going to go from 0 to 1. And it did. Now it's going to break out of the structure. It's going to leave this whole case structure now because we're going to hit this break statement and it's going to make it skip out of it. Bam, and it did. See that? Skipped out of the whole thing. Cool. Step over, step over, step over. All right, so it's asking us now, do we want to continue? I say yes, I do. I'll give you one more of these as an example. Let's buy a bagel this time, okay? Step over, options, display again, and let's do a bagel. And let's not have Nate type up there. All right. All right. Let's choose bagels. Okay, cool. And let's step into it. And our variables are here. All right. It's going to be 5. So when I step over, it's going to jump right to 5. Bam. And so it skipped all these other ones because they don't match. So system.out.println bagels. It's going to display it. So if I go to my output and I say step over, we get bagels. Then it's going to increase our bagel cost. If we look at our variable, right now it's 1 for our cost. And then if we step over it, it's going to be 3 because bagels were 2. So 2 plus 1 was 3, and therefore it's 3. Then we're going to skip out the rest of the structure. So we're getting out of our switch case structure. And it's going to ask me now, do you still want to continue? Prompt me for the input. I'll say false. Cool. Step over. Well, it's now false, so it exits. And now we're going to display our output. And the bill is $3. And there we go. That's the end of our program. So that's the difference between a switch and an if. Not much at all, really. It's just the way you write it up. Except for the fact that if can do more things that switch cannot do. But that covers several things here. It teaches you how to do if statements, how to do switch statements, and how to do while loops and do while loops. Well, do while loops. While loops are the same thing as a do while loop. Essentially, I could write this another way and it would do the same thing. So if I went in here like this, I could come in here and cut that out, change that from a do like that, get rid of my semicolon at the end, and that's valid also. And this would also work. And I'll prove it. This is a while loop versus the other one was a do while. So if I run this here, figure out my choice, and I could say something like 3, and I could say true, I could say 4, and I could say true, and I could say 5, and then I could say true, and now we'll have $5 of purchases. And let's do one more. Let's do peanuts. We haven't really been doing peanuts. So then let's say false now. So it'd be $6. Yep. And there we go. So that also works. So you can also do a while loop. Works just like a do while loop, but on the do while loop, because the condition test at the end is what's called a post-test condition, post-test loop. It does its test at the end. So therefore, the do while loop will always execute at least one time. This is a pre-test loop. The while loop is a pre-test loop, and what that means is it does its condition test ahead of doing the code. So it won't do any of this code until after it's already tested this condition. So this is probably more commonly used than your do while. Do while is not used as much, but both can be used. The only time you use do while is if you wanted the loop to execute at least one time um, prior to being tested. You can do the same thing as a while loop just by saying like buying equals true here, for instance, at the top. As long as you did that, you'd be fine too. I mean, it's whatever. So most people just end up using while, to be honest. But do while is there, and that's how it works, and that's what you can do with it too. But this is the while one right here. So most people use pretest loops. It tends to keep you out of trouble more. So that's why people use it more often. There's one more loop, as well as two more really, 4 and 4 each. We'll have a look at them later on, but we'll see how that works. But for right now, this is the while loop, and it gives you an idea of how to do it. Well, my name is Nate Nessler. This is for Hyperactive Studios. Thank you very much.